All right, welcome to the next part of the video, and what we're going to do here is look at the domain of a function and talk about what that is. All right, so the domain of a function is the set of all of the permissible values of x. To find a domain, you can start by asking, is there any value of x that causes the function to be undefined? And what we'll do is we'll look at different cases. First thing we're going to do is talk about what a rational function is and how you figure out what its domain is. Okay, well, a rational function, you can think of that as a fraction, and really what happens is you've got a function in the numerator and a function in the denominator that are polynomials. All right, so what you want to do is anytime you have a fraction, you can't have 0 in the denominator. Okay, you can't divide by 0. That's undefined. All right, and I'll talk a little bit about why that is in just a minute here. So the idea is this. I want to show you this first of all, because a lot of times students don't understand why you can't divide by 0. So I'm going to talk just a little bit about that. So if you had a long division problem, like if you had 12 divided by 4, you know that that's 3. And the reason you know 12 divided by 4 is 3 is because 3 times 4 is 12. Division is the opposite or the inverse operation of multiplication. Well, let's say that you had something like this. Let's say that you had 0 divided by 5. Well, that answer is 0. You can check your answer and prove that it's right because 0 times 5 is equal to 0. But if you divide by 0, kind of doesn't make any sense. So if you had 10 divided by 0, okay, the idea is no matter what you think the answer is, if you tried to check it, if you took that answer times 0, you would never get 10, you would get 0. Okay, so it doesn't make any sense really to divide by 0. Just conceptually, if you think about this, you could think of this problem as you have 12 cookies divided among 4 people. Each person gets 3 cookies. That's logical. This one's even logical. You have 0 cookies. You divide among 5 people. Well, those 5 people don't get any cookies. That's logical. But if you have 10 people and you divide, if you have 10 cookies and you divide by 0 cookies, then it doesn't make any sense really. Okay. All right. So in other words, if I showed up to class, I had 10 students, and nobody showed up to class. I had 10. I'll keep saying that backwards. If I have 10 cookies, no students show up to class, and I can't even do any division. Right? The teacher gets to eat all the cookies, I guess. All right. So that's how that works. So I think it's important that you understand that. Then, okay. All right, so what we do is we try to figure out, if we have a rational function, what makes the denominator 0. So what we do is, a lot of times you can do this in your head. You just look at that denominator, and what you would end up doing is you would just say, okay, what makes that 0? You can generally do that in your head sometimes. So you could add 6 to both sides, and if you did that, you would have x equals 6. So what happens is you have a problem. If x is 6, you get 6 minus 5 over 6 minus 6, so you get 1 over 0, and you can't do that division. That's undefined. So what we would say, when we're doing a domain, you're telling me what x is. X is actually every number except 6. So the way you can do this, and I want to show you this inequality first of all, and show you what that means. You could actually graph the solution, the domain, on a number line. So the key thing is you have 6. Well, the problem is you can't be equal to 6, but you can be everything else. Okay, everything else gives a numeric value other than 6. So on your inequality, this inequality here is going infinitely to the left, so you would say that is negative infinity to 6. To exclude that 6, you use a parenthesis. All right, that's important. You got to exclude that, so that's why you do that. Okay, then everything past 6 works. So you do a 6, then infinity to the right, and then you usually use this union symbol which joins those two solutions together. So it's everything except 6. That's how you write that in an inequality. So that would be the way to write that in an interval notation. All right. And then an inequality, what you can do is you can just say this. You can just say the set of x, and then you can put the bar and then just say x is not equal to 6. And that's good enough. What you're implying is it's every number except 6. All right, so you can write that interval that way, right? All right, now the next problem is the same idea, except it's a little hard to do in your head. So what we're going to do with this is we're going to take that denominator just like we did on the last problem, and we're going to set this equal to 0. All right, now before I do this, I want to kind of do this a little bit as I'm doing these problems. I want to do my graphing calculator on the last problem. I'm going to put in y equals, and then I'm going to put in parentheses x minus 5, and then divide by x minus 6. So this is worth doing with me on your calculator as you're watching the video. Then I'm going to just do a standard window. So I can go zoom 6. And what I want you to notice is you have a graph everywhere except 6. Right there, 6, you have this break in the graph. The other thing that you can look at is if you go to your table of values, second graph, you'll see that you have an error at 6. That's because you're dividing by 0. Every other number is going to have some function value then. So you can oftentimes look at your function on a graphing calculator and see if you've done that correctly. So it's everything except 6. You have function values. Okay. All right, now this next thing, what you got to be solid on is you have to know how to factor. And I do see a lot of times students in this class don't have good factoring skills. So this is like the opposite of FOIL. Okay, I'm going to just kind of at the side give you a little preliminary information because this hasn't really shown up in the class yet much, I don't think. So if you had something like this multiplication problem, okay, what happens on this is, and let me change this just slightly here. Let's change that to like 8 or something like that. So what you're doing is you're multiplying the x by both things. Okay, a lot of times teachers will teach this as FOIL, meaning the first terms, the outside terms, the inside, and the last terms. So you're doing x times x. Okay, x times x is x to the second. Anytime you multiply something by itself, it gives you a second power. The outside term, you're doing x times 8. Well, that's just written as 8x. It's a positive number, so I put an addition symbol. The inside term is this one, so you're doing 2 times x. And all you can do is write that as 2x. Again, that's a positive number. And then the last terms are the last things in each parenthesis, so you're doing 2 times 8, which is 16. So again, you're doing x times x, and then x times 8. That's like a distributive property, which we have done. And then you do the distributive property with 2. 2 times x, 2 times 8. These are like terms, so you would get x to the second. That's like 8 apples and 2 apples is 10 apples, so you get that. So what factoring is the reverse process of doing the FOIL. So when I go through this, that's the first term. That's the result of the first term. That's the result of the last term. And then this term here is the result of the outer and inner added together. So you have to know that in order to create your factoring. So what we do is we draw 2 parentheses. And the first term's easy. That's got to be x and x. It can't be anything else because x times x is x to the second. Now the last term, there's 2 possibilities. It can either be 1 times 6 or it could be 2 times 3. All right, and you just have to try one. And what you're trying to do is you're trying to see if you can make these add up to 5x. Well, it's easy to make this add up to 5 just by doing 2 plus 3. This one can be added up to 5 by doing -1 plus 6. But you're going to find this combination isn't going to work. And I want to show you why on that. If you put a 1 and 6 in here, like this, then this inner term would be 1x. This outer term would be 6x. If you're going to make that add up to 5x, then you'd have to have a plus and minus there. Okay, so the thing is, this would be wrong though, because that last term is -6. Okay, and the last term is supposed to be 6. So that doesn't work. And if these things factor, they only factor one way. All right. So what I'm going to do is I'm going to redo this. I'm just going to put this over here. And we're going to use 2 and 3. All right. So it goes like this. We'd have x and x. We'd have 2 times 3 to get the 6. And then this inner term is 2x. The outer term is 3x. We want this to add up to 5x. This is kind of the clincher that tells you how to put this together then. All right, so we got that. We want that to be 5x. So in order for that to be 5x, you have 2 plus signs. Okay, so that's the right factoring. If you FOILed this out, so you would have x squared, you'd have plus 3x plus 2x, which is 5x, and then 2 times 3 is 6. Okay, so what you do next is you take each factor and you set each factor equal to 0, and you solve these two equations, which you can do in your head. You could subtract 2, you would get x equals -2. Here you could subtract 3, so you'd get x equals -3. Okay, so there's 2 things that cause this denominator to be 0. So again, I'm going to do a number line, just to kind of help you visualize what's going on in this problem. So we have 2 things going on. We have -2, we have -3, and we can't be equal to -2, and we can't be equal to -3. I'm using open circles instead of parentheses on this, just because it's sort of a visual tool. So on the number line, we have to write 3 intervals. This interval, this middle interval, and that right there. So it goes like this. This interval is infinitely to the left, and then to -3, you exclude the -3, so you use a parenthesis. And then the part in the middle is just starts at -3, ends at -2. And then the part on the right goes infinitely to the right of -2. So you would write your interval like that. So that would be how you write that in interval notation. That's the domain. So it's everything except those 2 numbers. For an inequality, you would just say set of x, and you just tell me what it's not equal to. X is not equal to -2, and x is not equal to -3. Okay, so you write it like that. All right, so that factoring is going to show up. That's something a lot of students in this class have to work on. And that's something those of you that are in the 093 class will be working on a lot, is practicing your factoring skills, because it's pretty important. Okay, so I'm going to have you go to the next page, and let's give you a little time to try these 2 problems. They're pretty similar to what I did, and see what you come up with. All right, so you can go ahead and check and see if you got these correct now. So again, this one, what I did, all I'm concerned about is what makes the denominator 0. So I solved this equation, which would give you x equals -2. So that really means it's every number except -2. And you don't have to do this graph. You can do that. I do that. Sometimes it helps students write the inequality. So you're to the left of -2, which is this, and then you're to the right of -2, which is that interval. As far as your inequality goes, you just write it like this. Set of x, x is not equal to -2. Now I want you to keep in mind that again on problems like this, I'm going to do this on both these problems. This problem you put in your calculator like this. You have x plus 1, and then divide by parentheses 5x plus 10. Okay, and if you did just a zoom 6, okay, notice that you have a break at -2. So the graph doesn't really exist at -2. There's a big break there. If you went to your table of values and kind of went through this, you'll find you have an error. That just means you're dividing by 0 there. So you can't you don't have a function value there. Okay. Second one's a little bit harder for students because of the factoring. We set the denominator equal to 0. And again, this is your first term, that's your last term, that's your outer and inner added together. So when you put this together, just go like this. Okay, the first term's got to be x and x to get x squared. The last term's a 12, so you could have 1 times 12, 2 times 6, or 3 times 4. The only way you're going to get a 7 out of this is by using 3 and 4. Okay, so I put a 3 and 4, doesn't matter what order. That's a 3x. The outer term is 4x. If you're going to make those add up to 7x, they both have to be positive numbers. So you put plus and plus like I did here, and then set each factor to 0, so you get -4 and you get -3. So this one, the answer would be set of x is not -3 or -4. The interval goes like this. You got to have 3 intervals because there's 2 places where you're undefined. So you say left of -4, between -4 and -3, and to the right of -3. So that's how that goes. Now I'm going to do this one also on the calculator and show you how this goes. Right? So I would put this in like this. I have to have parentheses around the numerator and denominator when you graph this. So you have that. Okay, then you put x the second, and then plus 7x, and then plus 12, like that. So I want to just show you if I do a graph, there's 2 places, kind of hard to see this on here, but there's 2 places where the graph breaks. One of them is at -4, the other one's at -3. If you do your table of values, you'll see those 2 errors popping up there then. So it's everything except those 2 numbers. All right, so we'll move on. Pause if you need to work on this a little bit, and I'm going to go on to case 2, where we deal with square roots. All right, so with this one, we're just going to focus just on square roots. All right, so you got to understand the type of numbers you can take a square root of. Okay, you can only take the square root of 0 or positive numbers. That's the only thing that makes any sense. You cannot take the square root of a negative number and get a real number answer. Okay, the way you look at this, kind of think of it like this. The square root of 0, all a square root is what number do you multiply by itself that would give you what's under the symbol? That would be 0, because 0 times 0 is 0. If you do the square root of 4, a positive number, that's 2, because 2 times 2 is 4. You do the square root of 100, that's 10, because 10 times 10 is 100. What happens, though, is if you do a negative number, it doesn't make any sense. So if you had the square root of -4, okay, the answer can't be 4, because can't be 2, because 2 times 2 is not -4. The answer can't be -2, because when you multiply 2 negatives, you get a positive, so that doesn't work either. And you can't have 1 negative and 1 positive. It's got to be the same number, so that doesn't make any sense. Okay, so what you got to do, if you're going to find the domain of a square root function, you set the expression under the square root symbol greater than or equal to 0. But if it's in the denominator, then you have to set it greater than 0. So the reason is this basically. Remember, you can't have a 0 denominator. So if your square root is below, then that can only be a positive number. Okay, that can't be. You can't have 1 over square root of 0, because that would be undefined. Okay, so we got that. So what we do on these problems then is we do this, and you can check this on a graphing calculator too, like I've been doing. So this one, we have a square root. So what you do is you just write whatever's under the square root, and we know in this case that this is greater than or equal to 0. So you solve that inequality, and of course we've learned how to solve inequality. So you can either move the 5 or you can add 5 to both sides, and then that will end up giving x greater than or equal to 5. Now see, that's your domain. So we would just say set of x, and then we'd say x greater than or equal to 5. That's how you write that inequality. If you do this in an interval, then it'll go like this. So here's 0, here's negative, or here's 5 out here somewhere. So really what this means is you'd have a bracket and then shade to the right. Okay, so we're including the 5 on that. So we would just say in interval notation 5 comma, infinity. So what this means is every number bigger than 5, including 5, will give you a function value. So let me show you what happens on a graphing calculator on this problem. Okay, so you put this in like this. You go second x squared to get the square root to come out. Underneath that, you put x minus 5. Okay, like that, then we graph it. Well, what you're going to notice is the graph comes up for 5 and beyond. Okay, so it does that. And the other thing is, if you did your table, you're going to see all these errors. Okay, if you do all of these numbers below 5, you're getting square roots of negative numbers. But once you get to 5 and beyond, you start getting answers. See, okay, so that'll kind of help you maybe to look at that and reason that out then. Okay. All right, so I'm going to pause this for a second and get rid of this control thing. That happens sometimes. I think that may do it. Okay, hang on. Oh, come on, you stupid thing. Now, why does that... What made that come up? You know, what? Oh, come on, stupid thing. Okay, so I think I got everything working here again. Okay, so what you got to do on this one is the same idea. This part's under the square root. That's what you're concerned with. So this time there's a slight difference. You set that greater than 0, okay? Because see, this thing right here can't be 0 because you can't have a 0 denominator. So you solve this inequality. So then what you can do is add 3 to both sides. So that'll give 2x greater than 3. Then you divide by 2. And then you would end up getting x is greater than 3 over 2. And you just leave it that way. You don't have to write that as 1.5. So you just say set of x is greater than 3 over 2. Okay, for the interval notation, again, if you need to do a number line, you can, but you don't have to. Okay, the idea with this is you've got 0, you got 1, you got 2. So this is 3 halves is 1.5. So the graph goes like that. So in interval notation, you would just say 3 halves to infinity. Okay, so that's how that goes. You can put that in the graphing calculator and you would just see a graph existing only when you're bigger than 3 halves. Okay, so I'm going to put that in because it's always worth kind of going through this. So if you put in the numerator, you would go x minus 1. You put in the denominator, that would just be square root 2x minus 3. Okay, graph that out. That's kind of an interesting looking graph. Okay, that's 1.5. You have a graph at 1.5 and bigger. Okay, so that's what kind of happens on that is once you're at 1.5, but to the right of that, you have a graph. You don't have anything going on over here. If you did your table of values, you would see all these errors, you know, and 1.5 is where you start, past 1.5 is where you start getting numbers. Okay, so let's see, go ahead and let's see, you can pause and go ahead and do the next 2 problems, and then we'll move on and look at one other case. So I'm going to pause, work these out, come back and check and see if you did it right. Okay, so here's what you should have come up with. So the first one, if you get everything set up right, it's pretty easy to do. This one, you're just doing set what's under the square root greater than or equal to 0. And when you solve that, you get x greater than negative 3. So this just means everything bigger than -3, including -3, is going to give a function value. Okay, and then in interval notation, be sure you have a bracket, because again, what you're doing is you're including that like that. Okay, then the next problem down here, since this is in the denominator, you don't do greater than or equal to 0, because this thing can't be equal to 0 because it's in a denominator. So you do this inequality, that'll give you this. Interval notation will be -2 to infinity. Okay, so hopefully you got that okay. Pause if you need to. I'm going to go ahead and move to the next thing here. So the third case here, we'll kind of do this, and then that'll wrap up the video. This is a polynomial and a linear function. Okay, so the domain of any linear or polynomial function is all real numbers. Okay, well, the reason is if you have a linear function, remember linear functions go f of x equals mx plus b. Well, you're going to have a line. So the thing about this is x can be anything on this. X can be any number, because you can always take any number, multiply it by a number m, and then add to b. So you're always going to get everything works. You don't have a denominator or a square root or anything like that. A polynomial function would be something kind of like this. I'm just going to give you an example of a polynomial function. What a polynomial function is you just take x, you can take as many or as few as you want, and you make sure that the exponents are whole numbers, and then you can add or subtract. You can put a number in front, anything you want to. It can be fraction, it can even be a square root or something. The thing about this is you can't think of a number that you can't multiply out 3 times. Okay, every number can be squared. Every number can be raised to the 7th. So x can be anything on these. Okay, so what you want to be able to recognize on this last example is this is a linear function. And that's what I'm saying on here. When you're looking at this, I'm asking the question, is there any number that cannot be multiplied by 2 added to 3? No, every number that you can think of can be multiplied by 2 and then can be added to 3. So the interval is all real numbers. So you write the all real numbers as -infinity, infinity. And then for the inequality, you don't really write an inequality. You just say, it's okay to just say all real numbers, and that's sufficient for how you would write your answer. Okay, all right, so if you spot that you have a linear function, you're automatically going to know its domain is all real numbers. Okay, the second example is a polynomial, and when you have a polynomial, it says, is there any number that cannot be raised to a power? No, every number can be raised to a power. So there's no problem with x on this, so you would have exactly the same answer. That was a no there. And then you just say all real numbers. Okay, now see, what you have to do is you have to know that when you have a linear function and when you have a polynomial function. Now I'll show you one thing on this real quick, and then that will close off the video. So if I was to graph 2x plus 3 on my graphing calculator, okay, well, the line goes on forever. There's no breaks or anything in the graph, no problem areas. The table of values, you'll always have a value for y. You won't have any errors. If you graph the polynomial, you have 2x to the third, and then we have minus 4x to the second, and then plus x, and minus 10. So if I graph this, you can't really see this. I'm going to do a little zoom out thing here. I'm going to do this zoom out, kind of adjust the window a little bit. And you can see that this graph goes on forever. There's no breaks. The table of values, you would always have a y value for every x value. So you can always kind of help you understand that by looking at your graphing calculator. All right, so that will wrap this part up. So good luck. Okay, there's 3 cases that you're working on, and hopefully you'll do okay with that. Then I'll record the last video on what's called the difference quotient.